Let us discuss momentum in one direction. As shown on the screen, we are considering two objects. Let's consider two balls. They are moving in the direction as shown. Okay. Ball 1 has a mass of m1 and ball 2 has a mass of m2. Now, when we talk about momentum, conservation of momentum, total momentum before collision should be equal to total momentum after collision. Okay. So what is the total momentum before collision? The formula for momentum is mass times velocity. So u1 is the initial velocity of the object 1 and u2 is the initial velocity of the object 2. So the total momentum before collision will be momentum of object 1, which is m1 u1, plus momentum of object 2, which is m2 u2. Okay. Now after collision, what's happening here? If you look at it, both the objects 1 and 2, they are stuck together and they're moving in the same direction as before, to the right. Now when we are talking about velocities, we have to include the directions of the velocities. Now in this example, as I've shown here, both u1 m1 and m2, both the object 1 and 1 2 are moving to the right, and in physics to the right is always taken as positive. So object 1 has a positive initial velocity, which is u1, and object 2 has a positive initial velocity, which is u2. So after collision, as shown here, they are stuck together and they are moving in the towards the right. So the total momentum after collision will be, let us consider the velocity of both the objects since they are stuck together and moving in towards the right. Let us consider the velocity of the objects after collision to be v. Both 1 and 2 has the same velocity because they are stuck together. So what will be the momentum after collision? It will be m1 plus m2 multiplied by v. So this is one example of law of conservation of momentum as shown. So total momentum before, when the objects were moving separately, should be equal to total momentum after, when the objects were moving together. Okay, this is one example. Now let us consider the second example. We are again considering two objects. Both the objects are again moving towards the right. So these objects of mass m1 and m2 before collision has a velocity of u1 and u2. Okay, now what's happening here? After collision, if you look at it, again they're moving, but in this case they are not stuck together. After collision also they are moving separately. So now let us be, since they're moving separately, both of them have different velocities after collision. So let us consider the velocity of final velocity of the object 1 after collision to be v1 and the final velocity of object 2 after collision to be v2, applying law of conservation of momentum, which is total momentum before collision should be equal to total momentum after collision. What is total momentum before collision over here? m1 u1 plus m2 u2 should be equal to, what is the total momentum after collision? m1 v1 plus m2 v2. Before and after collision, if you look at it, both the objects are moving in the same direction towards the right. So that's why all the velocities have a positive value. Let us consider the third example now. These two objects 1 and 2 are again moving to the right. Okay, mass of object 1 is m1, mass of object 2 is m2. Initial velocity, since they are moving to the right, is plus u1, and initial velocity of the object 2 moving to the right is plus u2. After collision, what do you see here? After collision, you see that object 1 is moving to the left and object 2 is moving to the right. Again, let us give some values for velocity. So the mass of object 1 is m1, the mass of object 2 is m2. The velocity, final velocity of the object 2 will be plus v2 because it's moving to the right, whereas the final velocity of object 1 will be minus v1 because it's moving to the left. So in physics, right is taken as positive and left is taken as negative. Now let us apply the law of conservation of momentum to this scenario. So total momentum before collision will be m1u1 plus m2u2 should be equal to total momentum after collision. So m1 multiplied by minus v1 plus m2 v2. So this will be minus m1 v1 plus m2 v2. Okay, since the object 1 is moving to the left after collision, that's why we have assigned a value, we have assigned a negative sign to the velocity after collision for the object. Now again, this is another example where object 1 and 2 are moving in the opposite direction. Okay, so let us again consider the masses to be m1 and m2. Object 1 has a velocity of plus u1 before collision, whereas object 2 has a velocity of minus u2 before collision. After collision, what's happening here? Both objects 1 and 2 are stuck and they're moving to the left. So both has a velocity of negative v. So applying law of conservation of momentum, we have m1 u1 plus m2 minus u2 multiplied by minus u2 should be equal to, both the objects are stuck together, so their masses add up. So m1 plus m2 multiplied by minus v. So this equation now takes the form m1u1 minus m2u2 should be equal to m1 plus m2 v. You move the negative sign to the front. Okay, this is another example of law of conservation of momentum. Now another example, again another scenario where objects 1 and 2 are moving in the opposite direction, that is towards each other. So we will assign object 1 has plus u1 as the velocity before collision and object 2 has minus u2 as the velocity before collision. The masses, let us assume to be m1 and m2. In this scenario, what's happening now? We can see after collision, the objects are again moving away from each other. So object 1 is now moving to the left and object 2 is moving to the right. So now the final velocity of object 1, since it's moving to the left, becomes minus v1, and the final velocity of the object 2 moving to the right becomes plus v2. Now let us, both the objects again have the same masses m1 and m2. So applying law of conservation of momentum to this situation, momentum before collision will be m1 u1 plus m2 minus u2, because the object is moving to the left before collision, should be equal to, after collision object 1 is moving to the left, so m1 minus v1 multiplied by minus v1 plus m2 v2. Why? Because object 2 is moving to the right after collision. So this equation now takes the form m1 u1 minus m2 u2 will be equal to minus m1 v1 plus m2 v2. Or you can write this as m1 u1 minus m2 u2 equal to m2 v2 minus m1 v1. These are few of the scenarios of law of conservation of momentum.